I had been invited to be a guest speaker in Cookeville, Tennessee. The event was going to be a 2-day thing. We're going to have a youth emphasis day on a Saturday, and then I was invited to stay over and speak at the main worship assembly on Sunday. My overnight accommodations were at the home of a charming gentleman known as Leighton Sissom. Mr. Sissom had built a replica cabin on his property, and he used it plus his house to house the guest speakers and other people that would come through visiting missionaries or whatever. And we were all visiting in the den or the great room of his home. I think it was me and J.D. Swartz and some other guys. And he simply told us he was a retired teacher. Well, after Mr. Sissom retired for the evening, I looked around the library and discovered that in his library were engineering texts that had been authored by him. Oh yeah, he was a retired teacher, but he's a retired professor of engineering at Tennessee Tech. The next day at breakfast, I apologized for not calling him Dr. Sissom, and then asked him, hey, besides building replica cabins, what does a retired engineering professor do? And he explained that he did some consulting on the side as a forensic engineer. He was a forensic engineer for lawsuits. He told the story of how he'd won a major case against a motorcycle company, which will remain nameless, in which he demonstrated in court that the placement of a spark plug on a specific model of the bike had been placed such that if you had to lay the bike over and slide it, the spark plug was placed in a sufficient way so that it would generate sparks, not inside the internal combustion engine, but against the pavement, and lead to that plug creating those sparks, and those sparks igniting any fuel that might be leaking in case that this bike was involved in an accident. And he was representing a lawyer and a man who'd been burned very severely because he'd slid his bike and a fire had ensued, almost like a Hollywood stuntman. Because typically cars in accidents don't burst into flames, but this particular motorcycle did. He regaled us with the story how he'd entered the courtroom as an expert witness wearing these really thick welding goggles, a pair of welding gloves, and he ignited a pan of oil due to a flash spark and much looked like the Wizard of Oz. He said the one demonstration in and of itself won the court case. Well, as he's sitting here regaling us of all the things that he's proven that somebody did something wrong, I began to feel a little sick. And I started to sweat just a little. You see, I was the owner of a ropes course. I did guiding, private guiding in both climbing and rappelling. And one of my roles in this little company was I was in charge of the risk management. This man was my enemy. You see, as we talked about engineering, physics, and lawsuits, he basically said, hey, if you're involved in something, whether it's operating a piece of equipment or you're doing some kind of adventure sport and someone gets hurt or something fails to do what it's supposed to do and it results in an injury, he said there's only 3 possible scenarios. It was either designed wrong, it was made wrong, or it was used wrong. Now, as the guy who is bringing people out into the wilderness or walking them onto a challenge course and saying, hey, I want you to climb these rocks. I want you to climb this tower. I want you to zip this line. I want you to jump off this platform. I want you to swing from this giant swing. That was my world. Because if somebody got hurt, it was either because the equipment failed or somebody failed to do what they were told to. Now, if the equipment fails, then it's going to go back to, hey, did you use the equipment wrong? Did you set it up in a way that it wasn't supposed to be set up? Or did the person do something stupid and then they blame you? Well, he told us to do it this way. And so as we talked about risk management and surviving in this industry, we basically came up with 3 concepts. Everything either had to be fail-proof, foolproof, or fail-safe. Fail-proof is the way it's made. Foolproof is the way it's used. And fail-safe or redundancy is in case one of the 2 primary errors occurs or you get the worst case scenario, you still have some hope for survival. Now, I debated the idea of redundancy all the time in the ropes course industry Because, in the ropes course industry, the governing bodies, the ACCT and the PRCA, Project Adventure, OSHA, and ANSI, for all the emphasis that those guys put on redundancy, you've got to use 2 lanyards, you've got to use 2 carabiners, you've got to have a backup system on your pulley, you've got to have a backup on your bolts. But in the end, the users were wearing one harness, they were attached to one rope, and they had one lifeline cable. 3 different things that if any one of those things failed, it would be catastrophic. And the same thing was true in climbing and rappelling. For all of the anchors and the pins and the pitons and the chocks and the hexes and the cams and the carabiners, if the rope fails, Mr. Gravity wins. And wins violently because of sudden deceleration trauma. Primary cables do not fail. Dynamic kern mounted ropes do not fail. And if you operate on the chance that those things are going to fail or they're likely to fail, and you couldn't operate without redundancies, then you couldn't climb at all. There are certain situations where you have to believe that the thing that you're involved with cannot fail, or the probability, a possibility may exist, but the probability is so rare that you go ahead and behave as if it can't fail. And if you can't wrap your mind around that concept, then you can't climb. So there are some things that we used in the climbing industry that were fail-proof. And then there's things that are foolproof. Foolproof says we've made it as safe as it can be, but the end user can do stupid things. Climbing ropes and cables can and will break if they are overstressed, exposed to dynamic loads, get exposed to abrasion or shear forces. Foolproof is the idea that one should not be able to stand on a buffer and start it, although that can be done. One should not be able to put their car in drive unless their foot is on the brake. If you're pulling your car into the garage and it beeps at you and you decide, well, I'm going to go 2 more feet forward and nudge the trash can, your car will make the decision and stop you whether you wanted to stop or not. Now, I'm not a big fan of this. I don't want my car making this decision. I may one day have to plow my little truck through a horde of zombies, and I don't want my car telling me, nah, we've decided we're going to stop here and make all the zombies safe. I don't want my car making that decision for me. Your computer and your cell phone often ask you the question, are you sure you want to delete? Are you sure you want to hit reset? Are you sure you want to wipe the hard drive? All those settings are built in so that if you start to do something that is catastrophic, you get to ask the question, hey, is this something I want to do? These systems are in place to prevent human error. Now, I heard a comedian joking about this. He said he bought his wife a new car, and he said there's just too many safety things. There's lights that line up in the mirrors to keep you from changing lanes, and you have to have clearance before you can get from one lane to the other. If you try to go into this lane without turning on your blinker, your car will resist you. He said, I was in my wife's new car, and I was backing out of the driveway, and all of a sudden this little TV screen pops on, and it shows this safety video of a kid being run over on a skateboard. Who needs that kind of distraction? Foolproof is the idea that it protects us from fools and protects fools from themselves. And then the next thing you talk about is fail-safes. Some people call this as a redundant system. Redundant or fail-safe is the inoculation against Murphy's Law and Finagle's Law that we talked about last week. Murphy's Law says if there's 2 ways for something to happen and one of them will result in a catastrophic failure, then someone will do it that way. And then Finagle's Law is the idea that the worst possible thing can happen at the worst possible time. Well, fail-safes are inoculations against those 2 concepts. When it goes wrong, for surely it will, then there is another system in place to make up for the failure And there's another system in place to make up for when somebody does the thing they're not supposed to do or uses it in a way it wasn't supposed to be used. Fail safes or redundancies protect us from the scenarios where the fools outsmart the safety protocols. The example of a fail safe, I've always been fascinated by the guys who work on utility poles. I love to watch the system. Or they place a bunch of poles in line, and then they hang the pulleys on the poles, and they pre-string the pulleys with some kind of a small rope, and then they use the rope to bring a big rope through, and then they use the big rope to bring all the heavy utility cables through. But the guys who build those things are working in bucket trucks. And I drive by and I see these guys up in these bucket trucks, or I see these guys cutting limbs, in a bucket truck, and I see they've got a fall harness on. They've got a fall prevention harness, but all it's doing is preventing them from falling out of the bucket. My question is, what if the bucket falls? You see, I see these guys up there in these cherry picker buckets, and I think, hey, you need a rope attached from you to the pole. You need a rope attached to you and also to a tree, so that if the bucket leaves you don't ride it to the ground. Well, it turns out that these bucket trucks have a hydraulic thing, the hydraulic lifts, and it's called a pilot operated holding valve. Who knew? It was explained to me, and the best I can do with that explanation is that this valve only allows the machine to work with positive pressure. And if for some reason that pressure stops or there's a leak that develops, this valve, this pilot valve, will restrict the flow out of the cylinder, and then you maintain the positive pressure of this hydraulic system staying in place, and it prevents a catastrophic failure. Now, if I didn't explain that to you sufficiently, buy Daryl Pickles lunch and he'll educate you. So you have things that should be fail-proof, and we hope we can make them foolproof. And then we have things that are fail-safes in case the first two don't work. But just because something is unbreakable doesn't mean you should try to break it. It's designed to be unbreakable because it was built right and used right. Now, in relationships, those who suffer with or suffer from personality disorders often test the fabric of relationships just to see if they'll break or not. Now, this is misuse and sometimes sabotage. You see, fear of abandonment often results in abandonment because the bond is repeatedly tested. How much do you love me? Do you love me as much as I love you? And you test that bond, and not for integrity, but just for security, and it's not being used right. Or, you form a bond in a relationship, and it's to feel some emptiness, it's to feel some self-worth, it's to feel some self-concept deficit. Using relationships for those kind of things means the relationship wasn't built right, and it wasn't built for the right reasons, and those things don't often withstand being fail-proof or foolproof, or they don't have fail-safes. You see, in our relationships with friends, families, churches, communities, we have to assume that we started out with systems that are built with the potential for imperfection. They are imperfect. They're designed to be perfect, but they are imperfect. They're not made right because of the imperfect components. They are not fail-proof, and they are not foolproof because they involve people. And people are imperfect. And imperfect people act foolishly. Imperfect people are fooled. And imperfect people get caught up in foolishness. Now, let's make the distinction that we're talking about normal, flawed systems. I'm not talking about toxic, unhealthy, abusive, severe case scenarios. I'm talking about, you got two relatively healthy people. They're just imperfect, and they're trying to work out a relationship that is not fail-proof because it involves imperfect components, the people. I don't want a relationship that has the possibility of failure. I don't want to get hurt Some people may say, I don't want to get hurt again. I want to feel secure. And we all want that kind of security. Some people ensure that their safety with a failsafe. Some people ensure their security with a failsafe. If this gets hard, if it doesn't work, and sometimes that usually means if it doesn't work like I want it to work or expected it to work, or I have to work harder than I thought I'd have to work to make it work, then I'll just go somewhere else. I'll just do something else. I'll go back home. I'll go to my mom's. I'll find somebody else. Well, when that happens, that's because it's neither fail-proof nor foolproof, because people are involved. And so I understand that when I get involved with people, that it has potential for failure and it has potential for foolishness. Relationships should not come with contingency plans. People get married and say, well, and if it doesn't work out, no, you got married. It should work out. It has the potential not to, but you should overcome that potential with different kinds of fail-safes than the ones we've already talked about. You see, if I get into a relationship and I've already got a contingency plan, if I enter into a relationship with the idea that, well, if this doesn't work, I'll do something else, maybe I should ask myself, what am I doing in the first place? You see, if I enter into a relationship and say, well, this doesn't work out, I'll just move on, that says something about me that I'm unwilling to address, or something about the other person that I've chosen to ignore. There are only two reasons things break. They're made wrong or they're used wrong. And we already know most of our systems have an inherent flaw in them, and that would be us, the people involved. And not just me, but the other imperfect people as well. So to make up for the flawed component, we probably need to change the usage parameters, how it's used, our behavior, how we treat other people, and how we react to the treatment we receive from other imperfect people. There are no fail-proof and there are no foolproof relationships. But there are a few fail-safes. Patience is the fail-safe when perfection fails. When other people can't be perfect, when other people are imperfect, we are patient with them. Forgiveness is the fail-safe for failure. When people fail, we forgive them, or when we fail, we are forgiven. And love is the fail-safe for forgiveness. You see, even when we can't forgive, it's hard to forgive, or we just don't want to forgive, we can choose to love. Treat a person as if I love them, as if they're forgiven. We can love the unlovable people, and we can love people who don't deserve being loved. Love is the single, all-enduring, fail-safe attitude choice that allows us to survive when things are flawed, either by design, they're built wrong, used wrong, when we are wrong, or when we are wronged. Love's the fail-safe for that. Now, there is no fail-safe for love, because love never fails. If it looks like love failed, it didn't. When it appears that love failed, it is simply because someone failed to love.